Okay, good afternoon, ladies and gentlemen. Today, my colleague Carl and I are going to try to provide some answers to the question, what does mining need for the energy transition? So we both work directly for Caterpillar. I'm a senior account manager with a focus on mining microgrids, and Carl's our chief engineer on autonomy and automation. Okay, well, if everybody's read that, I'll move on. So as Caterpillar, we've been in electric power for a long time now, 85 years since we developed our first generator set. We're the world's largest generator set manufacturer, and we've got many installations globally. We've been doing hydrogen blending for a long time now, using syngases from some refinery projects. And we've been doing renewable hybrid microgrids since 2008. The first few of them were with US military and providing power to military camps in war zones. So on the left there you see our engine electric solutions. So a diesel generator providing power to electric wheel motors to enable propulsion through construction equipment, mining technology, and even in our Progress Rail group on the locomotive side. Now, it was some of the technology that comes from the drives used in those diesel electric solutions that came to develop our battery inverter. So a lot of the more capable battery inverters on the market come from legacy drive technologies. It provides a lot of attractive features for off-grid mining applications or off-grid scenarios, with very high overload capacity, fault current contribution, and extremely fast response times to be able to react to those voltage and frequency excursions that can take place when large loads are coming on or off an islanded power system. We've been doing microgrids since 2008, and we've now got many examples globally. We've got quite a number here in Australia now, 3 in total, with quite a number of energy storage systems with our dealer energy power systems. They come in a containerized solutions with the batteries and inverter in the same package at present, but we're developing other solutions to suit the energy transition, which will be available soon. We're adding to this energy storage mix often, and there's a lot of R&D going on in the background. Then on the right-hand side, we've got our battery electric solutions. So we've announced our early learner 793 class deployments with some of our larger clients globally. We're working with BHP, Rio Tinto, Newmont, Freeport, Vale, and Tech Resources to co-develop some of these machines and trial them in different locations around the globe, to see how they operate in hot environments, cold environments, dusty environments, etc. Now, this is a first for Caterpillar. Usually we do all our testing and commercially launched products ourselves. But to expedite the process, we're doing this hand in hand with some of our clients. And we've recently announced a program, a 4-year learning program called the Pathways to Sustainability. And we've had an overwhelming response to that as well. So we've got around 60 clients signed up to go through a 4-year learning journey with us. Now, some sites may not be suitable for battery electric technology straight away. So we're looking at efficiencies that can happen to existing fleet, alternative fuel types, but certainly battery electric machines are proving very attractive for many mining companies trying to hit their decarbonisation goals. But it's a lengthy process to put the appropriate infrastructure, additional power generation in, providing power to all the different charging nodes to be able to adopt a battery electric fleet. Now, as Caterpillar, this gives a bit of an understanding of our value proposition around hybrid power systems. In the top right there, you see various forms of renewable energy. We've worked with hydro, solar on many installations globally, and we're looking at some wind hybrid power systems as well. So each mine site's different, depending on the wind or solar resources that are available, space which is available, but we've got experts within our business who can do the techno and economic modelling to determine, is solar an option? Is wind resource available? Is the space available? You know, how big should the diesel or gas engine infrastructure be to be able to maintain a stable grid? Then below the renewables there, we've got our energy storage solutions. As I say, this is being developed, so we have small or compact energy storage systems available from our dealer locally, PSA. We have our PGS 1260, it's known as, which is the 20-foot containerized solution. Again, we have a number of them deployed throughout Australia and many deployed throughout the globe. This is the BDP 1000, which is a grid-forming battery inverter. Again, one of the more capable solutions on the market at present. At the bottom there, we've got our gensets. So we have, of course, got diesel and gas gensets. We've been doing that for a long time. We've also got hydrogen, 100% hydrogen generator sets. The difficulty is finding the hydrogen, finding the quantity of hydrogen available to run them at present. But we're looking at various fuel technologies, so hydrotreated vegetable oil, biodiesels. So we've got the ability to work with many different fuel types. And we recently deployed a hydrogen fuel cell at a data center application in the US with Microsoft. So we've got a lot of R&D going on to new technologies, and you know, there's no silver bullet. Every mine site's different. There's different technologies that are going to suit different mine sites. So it's an interesting space, that's for sure. And then on the left-hand side of the picture there, we've got our control platforms. So we've got microgrid control systems to be able to maintain a stable grid and ensure good power quality. Of course, the focus is maximizing the renewables because they've already been paid for, and minimizing the runtime of the gensets ideally to minimize the fuel usage, emissions, and all the maintenance that's required as well, of course, which can be costly. And then at the top, we've got our remote monitoring platform, which is known as RAM+. And this is a common theme across a lot of our technologies and a lot of our portfolio, which allows monitoring of the power system. Much like the dashboard of a Prius, you can see where the power is coming from at any one time and determine how the system's operating. So this is an interesting project we delivered alongside a partner in the Northern Territory on a mine site. It's a shaft excavation project. Now this shaft is 1.2 kilometers deep, so it's very impressive engineering that's gone into it. Now this company at one point would have used 3 1.5 megawatt generator sets and a load bank. So the load bank was required because there are regenerative loads that come from the excavation process. The new system utilizes 2 1.5 megawatt generator sets and an energy storage system. And it's allowed for some very interesting fuel savings, an added level of safety, and significant cost reductions. And it's been replicated a couple of times now, and yeah, the company we're working with say that they'll be replicating this technology wherever possible. So there's a lot of interesting type of projects that can suit energy storage. And yeah, it's an interesting space to be in. So here we have a battery electric 793 class haul truck. Initially, we retrofitted a diesel electric truck with batteries to prove the concept. Carrying load, it reached 60 kilometers an hour and traveled up a 10% grade at 12 kilometers an hour. It then traveled down the same gradient and was able to capture the regenerative energy produced by the braking of the wheel motors in the battery. This machine has since been scrapped, as retrofitted equipment such as this can't provide the reliability, performance and productivity that we demand from Caterpillar machines. The new battery electric 793 is different from the base frame upwards. It had to be to produce a machine. We're happy to carry the Caterpillar logo. Choose the best, choose Cat.
Thanks, Cam. As Cam indicated, we've made a lot of great progress in getting to the point where we've introduced our first early learner 793 battery electric trucks into industry. And in fact, 2 of these are going to operation this year at a BHP mine in the Pilbara. But the truck is a shiny bit. It's easy to think that just because we built a battery electric truck that we've got this solved. We think that the bigger challenge is really going to be in how we make large fleets of battery electric trucks as productive and hopefully more productive than the diesel trucks that we use today. And diesel truck today benefits from an incredible energy source, and it only has to be topped up with fuel once a day. Going to electrification, we're going to be having to manage the charging of electrified vehicles on a much more frequent basis, and that's going to impart all sorts of new challenges to the way that we operate mines. So the challenges facing us going forward, in addition to first building the truck, is going to be an energy distribution and an energy management problem. How do we get the energy to the trucks as efficiently as possible, maintaining productivity, and then manage that charge? Toward that, we have two main tools that we think are going to help us enable this. The first is the use of autonomy. Autonomy has already demonstrated that it is pivotal in improving the efficiency of how we operate and making sure that every minute of available time is productively utilized by autonomous trucks, so they're not wandering around the mine aimlessly, that there's not wasted assignment of trucks. They go with a purpose to pick up a particular material and deliver it to a particular target with incredible precision. That's going to be pivotal in how we manage the precious charging that we're going to have to distribute to these vehicles on a much more frequent basis. So we think autonomy is going to be a key enabler in how we leverage and we optimize the charge, how we assign a vehicle, how we determine what is available for charge at the site on a particular shift relative to production outcomes, and how many vehicles we can put on the road to leverage the site infrastructure, and then the delivery of the charging to the trucks. The next main innovation we have, and what I'm going to spend the rest of my time talking about in this presentation today, is our new dynamic energy transfer system, which is going to be, we think, revolutionary in how we transfer power to electric drive trucks, battery electric drive, and standard diesel electric drive trucks as well. So if you'll indulge me, there's about a 2-minute video here that does a very good job giving an overview. Then I'll come back and go into more detail about the specifics of it.
When we talk about the challenges of the energy transition, many of us think about replacing diesel trucks with battery-powered solutions. But the problem to solve isn't the truck itself. It's about how to safely and efficiently transfer energy to that machine. With a battery electric truck, energy transfer can happen in 2 ways. Statically, like when a truck stops at a charging station, or dynamically, transferring energy to a machine while it's working around a mine site. Today, dynamic energy transfer exists with diesel electric haul trucks by using overhead trolley systems like this. But trolley systems come with their own set of challenges. Trolley can take months to install and can be difficult to move around as a mine plan changes over time. When a truck is attached to the trolley, the operator needs to maintain a precise connection to the overhead cables, making it difficult to navigate curves in the road. The height of a trolley's cables also determines which truck models can connect and how high those trucks can be loaded. The size of the cables also limits the amount of energy that can be transferred to a truck. With our customers in mind, our team of innovators are redefining what it will take to run an electrified mine site, designing a solution that's nimble, more modular, capable of providing energy to machines when they're on the go, and recharging batteries at the same time. Introducing our new CAT Dynamic Energy Transfer System. This design is focused on transferring energy safely at the lowest total cost and more. The side rail will allow for greater flexibility. The system can be installed on flat haul roads, on grade, and around curves, enabling higher productivity. The connecting arm can be installed on either side of the truck and on multiple truck models, so you have options to fit your operations. CAT DET will also work with diesel electric models, providing immediate benefit to mine sites that want to lower their operating costs and emissions today, while providing flexibility for the future. No regrets. The system is also being designed to work with our command for hauling solution, merging together autonomy and electrification to provide a holistic site solution. On a mine site, we know every second,
So the DET consists of two main sets of components. There's the infrastructure, which includes the support poles and the conductors along which the hat transits to transfer the energy, and an integrated scalable power module, which is a fully contained ISO 40-foot container with all the switching and the relays that are required to convert the site energy that we're going to be creating through the technology that Cameron was discussing. And it's scalable to deliver between 11 and up to 33 kilovolts of AC power, which will be converted onto the rails into 2800 volts DC. There's a 3-rail system with the center being ground for safety. On machine, there's the deployment arm, which, as we indicated, can be mounted on either side, and it can be retrofitted to multiple models of machines that can all leverage this new charging infrastructure. The charging hat, these are very large contactor plates, which are really quite revolutionary and very, very efficient at delivering the DC voltage to the truck. And then there's the energy transfer box, which is on the truck, which intelligently manages bypassing the electric drive on the truck and then either driving directly to the electric motors on a diesel electric truck that's using it, or in the case of a battery truck, charging while it's also propelling. So the main advantages and the purpose of this is really to manage out-of-cycle charging. We don't want to have to assign the vehicles for, even though it's robotic, static charging. We want to have the machines moving as quickly as possible. It'll allow us to charge and propel at the same time, and it allows us to run multiple vehicles on the rail at the same time. It could be battery electric trucks, which are going to require about 6.5 megawatts of energy to charge the batteries while it's propelling it up specific areas of mine, versus a diesel electric drive truck, which would require 4 megawatts to allow it to drive. So that's the key thing that we wanted to emphasize here, is that this is an immediate enabler for improving greenhouse gas reduction by applying it to non-battery trucks. Electric drive trucks will be able to leverage this as well. Another key aspect of this is that we're making it very easy to install. We've learned a lot from, relative to easiness. We expect to be able to deploy about 1 kilometer of this in a couple of days. So it offers unprecedented flexibility. And we've learned a lot from our journey in delivering integrated mission-critical systems like autonomy and the importance of change management. And towards allowing a customer to succeed with what was described in an earlier session today as the mundane end of it. The exciting part is the truck, but the mundane part is how do you equip a mine to succeed and use technology like the energy transfer system, which is going to be fundamental to the success of the trucks, as quickly as possible. So this is intended to exemplify a focus on, on change, the importance of change management and equipping customers with all of the tools and the training and the processes they need to do this immediately. And toward that, we've developed a turnkey solution, which is described in this video that I'll just talk over. There's no sound, but we'll be delivering a fully proven set of processes and all of the equipment, including a small compact track type loader with an auger and a drill on it, which is used to deploy the infrastructure required for this, so that you can realize the flexibility of getting up to 1 kilometer of this deployed in a couple of days. So you drill holes, you then mount these screw-driven post holders into the ground. These can remain, and then you can deploy the poles that hold the conductors, and then you can come back if you wanted to relocate this. You don't have to take these out. You can if you've decided that you're done with that section of the mine. If not, they can remain in place. But the intention, as I said, is providing a turnkey solution, not only with an innovative way to deliver energy in a unique manner that's going to be required to deliver dynamic charging, but a turnkey solution to be able to do that. So hopefully we've shown, where we are in our journey from the infrastructure that Cam described that we're involved in equipping a mine with the generation required all the way through to the battery electric truck and the infrastructure and the processes required to leverage all those to the maximum initial productivity. Thank you.